Alrighty, here we go. We're diving into chapter 4 now. Yay! The beginning of this is going to seem a little weird because it's not going to be as completely exact and computational. It's more thinking and more spatial. So don't have a panic attack if this kind of gets to you. All right. Chapter 4, we're going to start diving into functions, relations, lot of terminology that you're going to encounter. So all of these words up here like correlation, trends, continuous, discrete, all of that stuff are going to be coming familiar to you in just a few days. All right. So grab your notes and here we go. All right. In this first situation here, it says each day, so this is the fall, several leaves fall off from the tree, and one day it's super windy. Gusty, big gusts of wind blows off a ton of the leaves, and eventually there's no more leaves on the tree. Draw a graph that would represent this situation, and I want you to put time as the x-axis. Now, you're thinking, hey, I have no numbers. I have no sense of time except, it's just a day, and I don't have the exact hours or anything. That's right. So really, I just want you to get a sense of what's going on here. Now, when I graph this, it really doesn't make sense to have negative because I'm going to put time across the bottom. Okay, so it doesn't really make sense to have a negative number for time. And it doesn't really make sense to have the number of leaves. We're going to put the leaves here, the leaves that are on the tree still. And it doesn't make sense for this to be in negative land. So here's what we're stuck with, okay? Each day, several leaves fall from a tree. So as I'm starting, there must be some leaves on the tree. So I'm going to start like here, let's say, okay? And then the leaves are falling off the tree. So as far as how many are left on the tree, this is kind of going down. As time goes on, there's less and less, okay? But then on one day, it's super windy and it's gusty, so we're losing a whole lot of them. And then maybe it levels out a little bit, but eventually there's none left. So at some point we get to 0. So we start here, kind of have a few, and then it goes dramatically down and eventually nothing, okay? That's kind of a basic picture. Which one looks most like yours, okay? Which one of those would you say describes what's happening on yours? More like A, more like B, more like C. So stop for a second, pause the video, see which one you think. All right, here we go. I would say we need definitely not A, because in A, it increases. That would be like in the springtime as more leaves are budding out. Both of these start and end at 0, B and C. This one has the real dramatic, more of a dramatic fall. This one kind of levels out. So I would say graph B probably most represents it. All right, let's look at another one. Temperature. The air temperature increased steadily for several hours and then remained constant. And at the end of the day, the temperature increased slightly before dropping sharply. Draw this on a graph. This time we're going to represent, again, time is going to be on the x-axis. I'm only going to use this first quadrant because it really doesn't make sense to go into negative land. Same thing with this. This is going to be the temperature. Okay, and even though I don't have the exact degrees, let's just focus here. Okay, time and temp. Here we go. All right, the air temperature increased steadily for several hours. So it's increasing and it's going pretty steady. All right, and I'm going to draw an actual line here. So it's increasing steadily and then remained constant. So think about what that tells you. Staying the same. At the end of the day, the temperature increased slightly. So I'm going to go up a little bit before dropping sharply. Boom. Okay. Now it doesn't say I get down to any sort of bottom. It's just dropping sharply. So we can let it hang there. That's okay. All right, now which one of the following graphs, now that you've got this drawn, which one looks like yours? Graph A, graph B, or graph C? I would choose C. Remember, increasing, constant, a slight increase, a sharp drop. Okay, now just because this went all the way down to the x-axis and yours didn't, that's no big deal. We're trying to get you into focusing in on the description and how that would translate. So as we're looking at some key words here and looking back at the examples that you had, you might focus in on things like increase or increasing, which means the graph is going to go up. Likewise, if you see something like decrease or any words that imply negative, that's going downward. Let's see. Sharply. So when we said things were happening sharply, that was more steep on your graph. When it used the word slightly, that to me implies either a slight increase or decrease, that it's a little more gradual, not steep. Let's see, thinking of any other words. Constant, that's also a good one. That one I'm thinking flat, perhaps. Steady or steadily, meaning it's either increasing steadily or decreasing steadily. That kind of gives me the impression that it's going to be going in a pretty straight, not kind of a zigzaggy pattern, that it's pretty at a constant rate of some sort, okay? These are, and along with a whole host of other words that maybe we didn't touch on, but it gets your mind thinking, when I see this word mathematically and on a graph, what does that tell me to do? Right? That's the kind of stuff we're going to head on to today. Now, we're going to focus in on two types of graphs. The first one is called continuous. Continuous, I want you to think connected, okay? Straight or solid line. It could be a straight line, it could be curvy, it could look something like this too. But continuous means there are no breaks in there. This would be things like the one I just did with temperature. It's going to get through all of the things in between. You just don't automatically outside jump from 10 degrees to 28 degrees. You have to increase through the rest of them. However, there's a little different situation, and this one is called discrete. Discrete only has distinct points on there, and so I like to think of it this way. With distinct, you have dots. Continuous is connected. Discrete graphs are things like, look at this example. You're actually counting people, okay? I can't have half a person, can't have a third of a person, okay? You would actually skip. When we did the ones with the leaves and it had dots, you're counting whole leaves like that. And it sometimes to represent a trend, we might connect them, but in reality, as we're counting things, countable objects are discrete, where you have just the dots, all right? And we'll practice more of this so it makes more sense. All right, let's look at these. Here's a situation. Sketch a graph. Tell me whether it should be dots for discrete or connected for continuous. The truck driver enters the street, okay? So he's driving, and he's driving at a constant speed, okay, as he gets on the street. Then he stops at a stoplight, constant, then stops, and then he continues. All right, so as far as speed versus time, he's getting on the street at a constant speed, and he has to stop. Now, is he just going to all of a sudden be zero? No, we're going to drop it off here. Okay, and then he's going to stay at the stoplight for a little while, and then he's going to start to continue on again. Now, it doesn't say if he gets back to that speed again, but this is a pretty good representation. This one, as you think about speed, this one should be a continuous graph. We can't just all of a sudden hop from 10 miles per hour, to 30 miles per hour, to 5 miles per hour, and so on. You travel through all of the rest of those speeds at the same time. What about this one? We have a bookstore, and the bookstore is going to sell between 5 and 8 books each day for 7 days. Okay, so what could happen, okay, is let's think about this. I'm going to put a blank page in here. Okay, so usually you put the time on the bottom, so we'll have days there, and then we're going to have the number of books. Now, this isn't a huge like Barnes and Noble store. This is just a small little bookstore. So they're selling between 5 and 8 books each day for 7 days. So we kind of have like day 1, day 2, day 3, day 4, day 5, day 6, day 7. Okay. And what did it say? Between 5 and 7 books? 5 and 8 books. Okay. So if we go 1, 2, 3, 4, 5, 6, 7, 8. 7, 6, 5, 4, 3. Okay, so if this is my day, like if I say like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, okay? So somehow this is going to bop around. So I could sell between 5 and 8. So maybe on Sunday, people are out and about shopping. That was 5. Maybe Monday is a little quieter, like 5. Tuesday, maybe that would be like 5 as well. Wednesday, Thursday, maybe that's quiet too. Friday, a little better. Maybe Saturday's a big selling day again. Okay. This one, it's countable objects, countable books. This makes more sense to draw a discrete graph with dots because it's a countable thing. All right. It's starting to sink in a little bit more. Here's another situation. What happens on this one? Sketch a graph for this one. Henry begins to drain a water tank. So maybe it's like a huge tank that you would have like at a farm to feed or to allow animals to drink, or maybe kind of similar to a huge pool. And he opens a valve. Okay, then the water starts draining. Then he opens another valve for a while. Okay, so you got 2 valves open with water pouring out. Then he closes the first one, so it's still draining, but only with 1 valve. And he leaves the second valve open until the tank is empty. All right, so put time as your x-axis. Water level, it can be the y-axis. This is the water tank. Okay, so we start and assume it's fairly full. And he's draining. So what's going to happen to the water level as time goes on? Water's pouring out, the water level is going to go down. Boom, boom, boom. All right. Then, for a chunk of time, he opens another valve, so it's going to go down faster. Then he closes that one, goes back and just has 1 valve open, like this. And that just happens until everything's gone. Okay? Sketch it so it looks something like this. This would be an example where it should be continuous again. Okay, continuous. Okay, because the water level doesn't all of a sudden hop, it passes through and it's a steady type of thing. So not dots, a continuous graph. Here are some good ones. Let's see if you can write a situation possibly for this one. Take a look at it. Pause the video for a second. All right, did you come up with something? Time went on. The speed was decreasing to a point. It was still going. It was steady, and then it slowed down again till it was nothing. Here's a possible situation. Car starts approaching some traffic and slows down, drives at a constant speed, and then slows down till it comes to a stop. Maybe you have one that's similar to that. Okay, cool. Let's look at this one. Ignore my little goober marks on there. All right, how about this one? You have the pizzas bought and the number of students, okay? What could be this situation? Think about it, pause the video, see if you come up with something. Here's what we've got. When the number of students reaches a certain point, we have to buy more pizza, okay? So if you just have a couple of people, maybe only need 2 pizzas. But once you get to a certain point, then maybe you want to bump it up to 4 pizzas, 5 pizzas, something like that, because you got to feed more people. All right, here you go. I want you to grab your textbook, focus in on this assignment now, and may the force be with you. Good luck.